Hey guys, today's topic about classifying and comparing polynomial functions. What is a polynomial function? It's a function that consists of variables and coefficients using only addition, subtraction, multiplication, and non-negative integer exponents. What that means? It means that the exponent, which is the power, cannot be a negative exponent or a fraction. It has to be a whole positive number. The classification of polynomial functions depend on the degree, which is the highest power of x. In the example above, 3x cubed plus 2x squared minus 5x plus 1, the highest power of x is 3. So this function is a cubic function. And the number of terms. In this topic, we will discuss 4 types of polynomial functions: linear, quadratic, cubic, and quartic. The linear with degree 1, quadratic with degree 2, cubic with degree 3, quartic with degree 4. So, the linear function, which is f of x equals x, has a degree of 1. Yeah, there is no power on the x, so it's 1. It's degree 1. It has a straight line shape. Quadratic function, which is f of x equals x squared with degree 2, has a parabola shape. Cubic function, which is f of x equals x cubed with a degree of 3, has an S-shaped curve. Quartic function, f of x equals x4, x to the power 4 with a degree of 4, has a W-shaped curve. And you will see each function in the next slides. First, the linear function. It has a straight line shape, and when you make the values of y, since there is no exponent, which means our degree 1, the values of x always will equals the values of f of x, which is y. That's why it's a straight line. When you evaluate minus 2 to the power 1, it will always be minus 1, minus 2, minus 1, it will be always minus 1, 0, 0, etc. Quadratic function. The same idea. You just evaluate the x's values and raised it to the power 2. Minus 2 to the power 2 equals 4. Minus 2 squared equals 1. 0 squared equals 0. 1 squared equals 1. 2 squared equals 4. Notice that there is no negative y values when the parabola is in the shape of happy face. This will be a detailed topic later. Cubic function equals x cubed. The same idea. You evaluate, raise to the power 3. This is an S-shaped. It must be an S-shaped. The quartic function has a W shape. Here it's not that obvious, but it's a W shape. The same idea. You evaluate, raise to the power. Next. What is the relationship between the degree and the differences? Notice this table. The linear function has a degree of 1, and when differences become constant at first difference, quadratic, the differences become constant at second differences. Cubic, differences become constant at third differences. Quartic, differences become constant at fourth differences. Did you notice a pattern? Yes, there is a pattern. As the degree increases, it takes more steps of subtraction for the differences to become constant. This pattern helps us classify polynomial functions even when we have only a table of values. So what differences means? Notice this table. Guess the degree. This table shows that the second difference are constant. So this is a quadratic function. So the relationship that when you know the difference, when the differences are constant, you will know what type of polynomial function it is. Polynomial functions have real-life applications. Linear function used to represent constant rate of change. Example, the relationship between distance and time when moving at a constant speed, like a car driving straight. This road is a straight line. It's a linear function, represents a linear function. Represent constant rate of change. Quadratic function describes curved motion and acceleration. Example, the path of a ball thrown in the air. This ball, when it's thrown in the air, it makes a parabola shape, which is a quadratic function. Cubic function shows the growth and the change of direction. Example, modeling population growth or the shape of some roller coasters. This is a roller coaster. It has many S-shaped. Finally, or last but not least, quartic functions. It's used in engineering and signal processing to smooth data or design shapes. Example, designing bridges and advanced mathematical curves. This example in the wallpaper is an example of advanced mathematical curves. This is used in trading. And we are done in this topic. See you later.